Hello class. In this lesson we're going to learn how to write equations of parallel lines and how to figure out if a pair of lines is parallel, perpendicular, or neither. So we want to figure out what the relationship is between two coplanar lines that are perpendicular to the same one. So we're going to use this diagram throughout the example, so make sure you have this jotted down. And we have lines L1 and L2 are both perpendicular to line K. What can we say about lines L1 and L2? Well, we proved this in a previous lesson, that when we have lines that are perpendicular to the same line, they're parallel to each other. And lots of reasons for that. One of them is you can say that the corresponding angles are congruent, right? Because these are all 90, so when the corresponding are congruent, they're parallel. And what do we know about the slope of L1? Well, we know it's perpendicular to K, and they tell us that the slope of K is M. And so since they're perpendicular, the slope would be the negative reciprocal. So -1 over M. What about L2? Well, L2 is also perpendicular to line K, so its slope will be -1 over M. So now what can we say about the slopes of lines L1 and L2? The slopes are equal. They're both -1 over M. So what can we say about the lines if they have equal slopes? We can say that they're parallel. And so the relationship that we have here, we have these two coplanar lines that are perpendicular to the same line, is that they are parallel, and also, this is our first important result, if two lines are parallel, then their slopes are equal. But what happens if what if we take the converse of that? Is it true that when the slopes are equal, that the lines are parallel? We don't know that yet. We haven't proven that. We only proved that in the other direction. So now let's look at what if we know that slopes are equal. So in part B here, we don't know that they're both perpendicular to the same line, but we know that their slopes are equal. So let's see, what's the relationship between L2 and K here? So to answer that, let's go through some questions, and ultimately we want to figure out what's the relationship between L1 and L2, because right now all we know is that their slopes are equal. We don't know anything else. So if L1 is the slope of M, what's the slope of K? Well, they're perpendicular, they gave that to us. So its slope will be -1 over M, right? Negative reciprocal. And we know L2 also has that slope of M. So how is L2 related to K? Well, their slopes are negative reciprocals. And we already proved that when we have negative reciprocal slopes, that the lines are perpendicular. So L2 is perpendicular to line K. If you want to, we go ahead and label that in our diagram. And what can we say about two lines that have equal slopes now? They're parallel since they're both perpendicular to the same line, like we said before. And so now if we combine that with what we had in part A, we can say that two non-vertical lines are parallel if and only if their slopes are equal. That means it holds in both directions. If we have two non-vertical lines that are parallel, then the slopes are equal, and vice versa. If two non-vertical lines have slopes that are equal, then they're parallel. That's called the biconditional because it holds in both directions. Now, why do we say that the lines have to be non-vertical? Well, when we have vertical lines, their slopes are undefined, so we can't really say that the slopes are equal. It doesn't make sense to say undefined equals undefined. It's not a defined value. It doesn't make any sense. So instead, to get around this, we say that any two distinct vertical lines, so distinct means they're not the same, they're parallel, so we don't have to talk about their slope. So example 2, now we have a point and a line, and we want to first figure out what's the slope of the line. Well, it's in slope-intercept form, so slope is the coefficient of x, it's just 2. So using what we learned, what would the slope be of any line parallel to this given one? Well, we learned from our theorem, that biconditional, that the slope would have to be the same. It would have to also be 2. So now we want to write an equation of a line that goes through this point and is parallel to this line. So there's two main ways that we can go about that. You can either look at point-slope form or slope-intercept form. So let's look at both. And it's really up to you to decide which one you like better. And also, if it's multiple choice, you could have the answers given in either form, or standard form. So you got to know how to convert from these to the other. If it's standard form, it's usually easiest to switch it around and make it slope-intercept form. So point-slope form, let's look at that first. So we know that our slope is 2, and the point is -3, 6. So remember, we're subtracting the coordinates. So when we plug in, that -3 is going to be a +3, and that +6 is going to be a -6. And that's it for point-slope form. Now for slope-intercept form, let's see. Well, we know the slope is 2, and the point is -3, 6. So we're going to plug those in. Move this down. And now we solve this to figure out what b is, and then plug that in to figure out our slope-intercept form. So add -6 to both sides, and we get the y-intercept is 12, so our equation is y equals 2x plus 12. So these are the same equation. So what would the slope be of any line perpendicular to this given one? Well, the slope was 2, and if it's perpendicular, the slope has to be the negative reciprocal. So it would be -1/2. Now here's an example. It has 3 parts, and we want to figure out if the pairs of lines, if the pairs are parallel, perpendicular, or neither. And we got to justify that. So as a refresher, they're going to be parallel if the slopes are equal. They're going to be perpendicular if the slopes are negative reciprocals, and they're not going to be either of them if they're not equal and not negative reciprocals. So all we have to do here is you want to write each equation in slope-intercept form, and then compare the slopes. So try A, and I'll show you my solution. So here, you should end up with these equations. So our slopes are both 1/2. So the lines are parallel. Try part B, same idea. Write them in slope-intercept form and then compare the slopes. Well, in this case, we end up with slopes of -3/2 and 3/2. Now, these are not negative reciprocals. Be careful. This fraction hasn't been flipped, right? So they're not the same, they're not negative reciprocals, so these lines are not parallel and they're not perpendicular. And finally, about these two lines? Well, if we figure out their slopes, we end up with 4/9 and -9/4, and those are negative reciprocals, right? The product is -1, so the lines are perpendicular. In this lesson, we learned how to write equations of parallel lines, how to figure out if a pair is parallel, perpendicular, or neither. Thank you for watching this video.